In this video, we'll be doing more examples of word problems solved by systems of equations. And these types of problems are often referred to as mixture problems and are notoriously challenging and problems that you'll see randomly in math class that people don't like. But we'll try to simplify them as much as possible. And again, focus on writing an equation and using those equations to solve it. And another thing I wanted to mention is these are not really business problems per se, but just assorted other practice problems. In your homework, I'm going to try to focus on business-related examples, but I'll throw in a couple other examples that may be in the sciences, chemistry, or whatever. But we'll go ahead and look at example number 2. You put some of your spare change into a jar and give it to the Red Cross, consisting of just dimes and quarters. You counted 96 coins, and they totaled up the value of your coins to $17.70. How many coins of each type were in the jar? And you could expand these to say having a jar of pennies and nickels and dimes and quarters and whatever. That would just be a lot harder because that would be 4 variables, and solving it would take more equations to get there if we were to develop this example. And also these examples are kind of dumb in that who's actually going to count? I mean, maybe this makes sense, but who's going to count all the coins and count the value, but not actually count the individual amount of each? But it's kind of like a puzzle. And in math, sometimes we're not doing things that are necessarily useful, but just using these puzzles as practice for seeing do we really understand how systems work and how they can be useful. But basically, what I want to focus on is again looking back at the word sentence, trying to extract equations from that. So basically, I have one thing I know is that I have 96 coins. That's one thing, and the other is that it's a total of $17.70. Those are actually going to create 2 separate equations as well. And another hint to help, and we'll notice I have a nice table here set up with all the information, but is to kind of collect what we know. And also thinking about what it's asking for how many coins of each type. What I want to know is how many dimes and how many quarters. So you could call that X and Y, or we could use Q and D. I want to know how many dimes and quarters. Yeah, Q and D to figure out how many of each type we have. Sorry, I confused myself for a second there. But notice like what I could do is call the number of quarters Q, because that's what I'm trying to find, and the number of dimes D. And those would be my variables to start with. And notice since I have 96 coins, what I know is that Q plus D is equal to 96, because this equation describes each individual quantity of coin, and the sum of both together was a given amount, the total. Now the second equation, I'm going to call it the value equation, but it's going to reflect, well, how much is each quarter valued at, and how does that reflect to a total cost? But since we obviously know how much a quarter is valued at, and you know it's 25 cents per quarter, basically what that would amount to is 0.25Q. That would give me the total value of all the quarters that I have. So say for example I have 4 quarters. That's going to be worth $1 because that would do 4 times 25 cents. That would be $1. But also, I know that the total value of all my coins is $17.70. But that would be the value of the quarters plus the value of the dimes. Since each dime is valued at 10 cents, that would be 0.1 times the number of dimes D. Like say I have 10 dimes, that would be $1. 10 times 0.1 is 1, which would give me the value of the dime. So essentially I've got here value of all my quarters, and then this one is the value of the dimes, and together they add up to the total value, which was the blue piece of information that I was given originally. But when all is said and done, notice that I have 2 equations with 2 unknowns, and again I could use algebra to solve this system. Let's go ahead and use elimination in this case, because usually I would suggest using elimination over substitution, but either way is totally fine. And I'm just going to vary it up for the sake of variation, and also practicing with decimals. But notice that in this equation, everything's all positive, and that's usually pretty typical about real problems. You don't normally have negatives in there. So what I would probably do is if I multiply this equation through by 4, or by 10 might be a better choice as well. Actually, I'm going to go ahead and do 10. That will make sure that these, like basically I want to make sure my variables are ready to be eliminated, right? That's kind of the main goal. So let me move over to here. If I leave my first equation alone, Q plus D is equal to 96. Let me just put a little wall there, so that's ugly. Just to know I'm shifting over here. And if I take this equation and multiply, I'm going to multiply by negative 10. And it's by 10 just so that this will become 1, and by negative so it will become minus 1. So what I would get is negative 2.5q minus 1d is equal to negative 177. And really, it was just another general strategy for dealing with equations with decimals is if you multiply by, say, 10 or 100, you're going to move the decimal place once or twice, which will simplify your equation. And by doing it, by multiplying by 10, I moved all the decimal places once, which is pretty easy. And that way, this equation is now ready to eliminate. I have d plus d and minus d. If I then add these things together, d minus d will cancel. And over here I'll have 1q minus 2.5q. That would be negative 1.5q. And that's going to be equal to 96 minus 177. And I'm going to use my calculator just because I want to be sure I don't mess that up in my head, which is negative 81. And then if I divide through by negative 1.5, this should give me the number of quarters that I have in my jar, 54. And once I have 1, we reverse the substitution and plug it back in. But I know the total was 96, so if I do 96 minus 54, that would give me my amount of dimes. So D should be equal to 42, the meaning of life. And there we have our answer. And again, I could check this out. Obviously, they add up to 96, but what I have not checked is that they actually add up to $17.70. But if I do, well, my quarters were 25 cents, so 25 times 54. And my dimes are worth 10 cents, to which I have 42. Those should all add up to $17.70, which they do, so we're good. In the next one, we'll do another mixture problem.